Have you ever felt a small shock from touching a piece of furniture or a doorknob? Why do you think that happens? Does your furniture hate you? Or is there something else going on? Let's find out. Our objectives are to learn about the electric charge and to understand how objects get charged. In ancient Greece, around 600 BC, Thales observed that amber, when rubbed with wool, acquires the property of attracting light objects like small bits of paper. Similarly, a plastic comb, when rubbed with dry hair, can also attract such light objects. The rubbed substances which show this property of attraction are said to have become electrified, and the electricity so developed is called the frictional or static electricity. Let us perform an experiment. Rub a glass rod with silk and suspend it with an insulating thread. Now bring another similarly charged glass rod near it. You can see that the two rods repel each other. However, if a plastic rod rubbed with fur is brought near another similar glass rod, the two rods attract each other. This attracting and repelling behavior is attributed to an entity called electric charge. These observations lead us to conclude that 1. There are two types of charges, and 2. Unlike charges attract and like charges repel each other. When the electrified plastic and glass rods are brought in contact, the charges acquired by them neutralize or nullify each other, and the rods no longer attract each other. The American scientist Benjamin Franklin named these charges as positive and negative. But from where do these charges come from? Like every substance, a glass rod consists of a number of atoms. Each atom consists of fundamental particles like electrons and protons. Like mass, they have another intrinsic property called electric charge. It is a scalar physical quantity and its SI unit is coulomb. Conventionally, the electrons are considered to have a negative charge, whereas protons are considered to have an equal amount of positive charge. Since each atom consists of an equal number of electrons and protons, the net charge on each atom is 0. Consequently, the entire glass rod is electrically neutral. The same is true for silk as well. But when the neutral glass rod is rubbed with the neutral silk cloth, the energy spent in rubbing is used to transfer electrons. A glass rod atom loses an electron due to friction produced during rubbing. The deficiency of one negatively charged electron creates an imbalance of charge. Hence, the glass rod atom develops a positive charge. This electron is gained by a neutral atom of silk cloth, and an imbalance of charge is created by an excess of electrons. As a result, it becomes negatively charged. The same process is frequently repeated during rubbing, and the glass rod becomes positively charged, and the silk cloth becomes negatively charged. Attraction and repulsion between charged bodies have many industrial applications, like electrostatic paint spraying, in which a body to be painted is positively charged. When the droplets of paint emerge out of the atomizer, they get negatively charged due to friction. The attraction causes negatively charged paint droplets to get deposited on positively charged bodies and avoids any wastage of paint. To summarize, electric charge is an intrinsic property of fundamental particles of matter. It may be negative or positive. In the SI unit, the magnitude of charge is measured in Coulomb C. Like charges repel and unlike charges attract each other. Electrostatic paint spraying is one of the many industrial applications of static electricity. So now you know what zaps you sometimes when you touch a piece of furniture. That zap is often fairly weak and you barely notice it. But on certain occasions, it also makes you jump back violently. Why is this the case? Why is the shock stronger sometimes but weaker at other times?